Okay, so last class, we already started to discuss how to design user-defined class. And generally speaking, we start with UML diagram. Okay, and for our time class example, last class we also showed, but let's just do a quick review. So you can use a big rectangle as it, and generally speaking, we have two parts. And we have all of the instance variables, is it? So in this case, we have like hour. Oh, and we need to identify its visibility, it's public or private. So in this case, the instance variable for the time class, it's all private. So private, we use minus sign. So the name of the instance variable and the type. And the next one is minute. And it's also integer. I should use this, okay, capitalize the single word, the next word. This is called camel case. Camel case, okay, that's a preferred in Java, okay, not underscore. And then the next one is MAMPM. The name of the instance variable and the type is character, as a character. And then the second part, for a class, we have two parts, attributes and the behaviors or interface, is it? And for the method, last class, we already learned, generally speaking, we have constructor, is it? Like in this is, and there is no return type, is it? So it's a constructor. And I remember we have another constructor, is it? And it also has the parameter type match the instance variable, is it? Like integer p hour, integer p minute, and char p am pm. It's a constructor. This is also constructor. Okay, it's a constructor with argument, is it? And then we have some get method, so accessors and set method, mutators. So like in this case, we have like a get hour, I remember. The return type is integer, okay. And the get like a minute, the return type is integer. And like a get AM, PM. And the return type is char. So those are accessors. And generally speaking, the accessor, the purpose is to retrieve the value of instance variable. Okay, the corresponding instance variables value, try to retrieve, not to change. Okay. So constructor, the purpose is to initialize the instance variables, okay. And then we also have like some mutators, like suppose set time. This is called mutator. Mutators is going to modify instance variable. Is it like set time? Then we have like the parameter. You list of the parameter, integer like minute, and like character p am pm something. Is it? And the return type is void. Okay. That's the set method. And I remember last we also have the toString method. And then return type is a string. So you just list all of the method, the name, the parameter, and the return type. Okay. So that's how a UML. So you first give this kind of framework, and then you do the coding. That's how this UML diagram serves. So let's take we have the constructor, explicit value constructor. We have the get hour, we have get minute, we have get EMPM, and we also have set time. And I forgot to put the set hour one. And we also have this toString. Okay. Okay, so that's regarding the general, a very basic class. This is just a very basic class design. Okay, generally speaking, you need to have instance variable, and normally instance variable are put as private. Okay, put private. And in OOP, there is a specific word for this. We call it encapsulation. Encapsulation. Okay, so if the visibility of instance variable, so if visibility is private, that means encapsulation. Okay, encapsulation is a lot of time we also call it information hiding. That means you don't want to expose them. So in UM diagram, if it's minor, that means its visibility is only within class itself. Okay, class itself. So that means you want to hide this information to external world. Okay, that's why we call it encapsulation. So basically, encapsulation is one of the property of object-oriented programming. Okay, later on we will learn some other fancy word associated with OOP, but always keep this in mind. What does encapsulation means? Okay, so that's regarding encapsulation, and then you may be curious, what exactly that means? Is it private and not accessible? Is it? So let's take a look. And I remember last class we also briefly discussed. So this is time class, is it? And we define those instance variables as private. Is it? And then, so this is a instance method. This instance method and the instance, they both belong to time class. Does it belong to time class? So inside this get hour method, you mention this instance variable. Is it? You can access directly just with that M hour. And you can also do some this dot M hour. That also works. Okay, later on we will explain that. But anyway, so here you can directly access. Is it? If it's within this class brackets, you can directly access it, no problem. Okay, that's why we say okay, it's private. Then for this example, so this is our class, and we also have a driver. The driver is that application with main method. Okay, with the main method, so let's take a look. So for this driver, okay, this driver, it's associated with a different class. Associated with a different class. Different class. Okay, so here be careful, okay. And like last class, I remember I kind of showed, but here before we do that, let's first take a look at this part. So anyway, so this is a different class, not the previous time class. Okay, within this, we have the main method, and then this is an application's entry point. Then the program can be run. Okay, then let's take a look. How do we use a class? Whenever you want to use a class, the very first thing to do is to create an object, or sometimes we call an object of the class, or sometimes you say an instance of the class. And how do we create one? We use that new. Okay, create new. And where the object is going to be with new, it's going to be on heap memory. Okay, heap memory. Be careful, okay? So then let's take a look here. Let's take a look at the second statement. So how do we create an object? So this is a Java variable, and the variable data type. Data type is what? Is type. Okay, and because it's an object, it needs some space. Is it? So that's why how you do is do new type. Okay, this new and this type, then it's going to create heap memory for T1. Okay, for T1, not T1, basically for whatever T1 reference. Okay, and this time parenthesis, basically here it's invoke time classes default constructor. Default constructor, it invoke. Okay, so create an object, rely on constructor. So the T1 is using that default constructor created. Then let's take a look at T2. So basically T1 is going to be initialized as what? As 12 a.m., the default one. Okay, the hour, the minute, and AM, PM with the default constructor, the one without a parameter. If you take a look at T2, then you call new time. It's still called constructor, and you plug in with arguments. So this time it's also invoke constructor. But this time it's the constructor, we can call it explicit one. Or the one with arguments, is it? So then the time is going to be 8:30 a.m. for T2 associated with it. Okay, so this is the concept of create objects. Create objects, probably let me draw here, okay. So we have, so in program, we have stack memory. And we also have heap memory. Okay, heap memory normally is dynamic. So it's a runtime, not in compilation time. Okay, so anyway, so in stack, you always have that main method. is it? And then we have that T1. And T1, it does what? It's called that new time. The new time then is going to allocate some memory. So that's the memory on heap. Okay, on heap. So then it has that 12 AM associated with it. Is it? So T1 is associated with this specific memory block on heap. Then same thing that T2, then it's going to be 8:30 AM. Is it? Then it's also reference. So that's related with that new time, 8:30 AM. Is it? Invoked, the memory is created and associated with all of the values. So this is called with this new, okay, at runtime, the memory going to be allocated. So now we understand those two objects. So T1, T2, both are called, so here, T1, we call it a time object, or we can call it an instance of time class. Same thing for T2, it's also a time object or an instance of time class, okay? But they hold different values, depends on the constructor who invoke, which constructor is get invoked, okay? And now, if you take a further look, you will see for T1, after this statement, what it calls is, it calls that T1 dot that toString method. So toString is an instance method of time class. Is it? So you can always access the instance method with the dot and following by the method name. Okay, you invoke that method, you call that method. And here, this toString method, we access the instance method from a different class. And why we can directly do T1 dot toString, that's because the toString is public visibility. And because it's public visibility, so it can be accessed in a different class, okay? So it's not necessary to be in the time class, but it can be accessed from a different program, basically here, okay? So you can directly access. And then next, let's take a look at T2, is it? If you take a look at T2 here, we also call T2 dot get hour. And why we can call get hour? Because get hour is defined as public. So if the method is defined as public, then it can be accessed even outside of the class. Okay, so other program can also allow it to access. And then we can also take a look here. You also call the set time for T2. Is it? And you keep call get hour, then toString. Is it? So we did call all of the so-called public instance methods here, okay? And like here, I already have that time. If I do T1 dot m hour, is it supposed to like assign to 10? Then if you take a look, it will see cannot find that m hour. Is it? So it has arrow. So this is wrong. Why you cannot access? It's because M hour is private. So it's not accessible outside of the class. Okay, not accessible. Outside of the class. So that's why we call it encapsulation or information hiding. Because you don't want to expose this information, this instance variable. You even don't want external to know that it does have this instance variable, completely hide all the instance variable hour, minute, AM, PM. So external world doesn't know. That's why, but you may say, oh, but I am able to get X to retrieve the hour. Is it? Yes, it allows you to. So that's why over here it provides some public accessible interface. It says, okay, I will let you to read that hour. So I authorize you the right to read this hour value. But this is kind of, you can understand it like the concept, suppose like you have a house. Suppose this is your house. Is it a house? And you have a window here, suppose, window here. And you have some furniture, is it? Some furniture. And for this furniture definitely accessible inside the house. Outside the house, if you don't provide the window, nobody knows that your house has that furniture, is it? But if you provide a window, let the furniture be shown, then definitely external, so other people can see that furniture, is it? But can they touch the furniture? No. You said, I only let you see it. I won't provide a method called touch my furniture. I only provide a method called view my furniture, is it? So then it's, you can control how you let external world to have some of what level of authority to regarding your furniture. So it's under your control then. So that's why we have the private and the public difference, is it? And for public, because it's interface, is it? So it's, you can control how to access that item. It's purely under your control. It's just a view, or you can also move, do something on it. Is it purely under your control? So that's the idea about OOP design. But you see, if you don't provide the window, then they even don't know you have that furniture. It's because that, oh, you can kind of see the, but you still have not a complete knowledge about the furniture, is it? Yes. So that's the idea about encapsulation. And then we kind of get the idea of how to use the method, is it? We can also see, if suppose I change this get hour as private, then let's get back to see. Did you see for this get hour, then it report has private access. That means you are not allowed to access. It report error. Okay, report error, then it's not accessible. So it's purely under your control. That's what we try to, try to see, to show. And once I change it back to public, then the error message is gone. Okay, so it's purely under your control. Okay, so that's a point here. And what next one? Let's see. We have another concept we haven't discussed here. If you take a look at this number of time, it's an integer, this variable. But within the data type, you have a special keyword called static. So then what does this mean? Okay, so this means this variable is called a class variable. Okay, class variable. Class variable means what? Means it's belong to class. And all those called instance variable. Instance variable. So instance variable means you first need an instance or object to access it. If you don't have an object, you cannot access this variable. Okay, be careful. So that's what's the difference. So anyway, so in Java, if you see the word static, then that means it's something class, like a class variable or class method. Okay, and related with this, and of course, inside your instance method, you still access it. So what here, this variable, class variable is going to do is want to keep track of how many time objects created. That's why did you see within constructor, we have the plus plus. So when you call constructor, it's when an object is created. So each time if an object is created, then you increment by 1. But did you see for instance variable, those instance variable only associated with specific object. Okay, and this number, it belongs to class. So all objects also own it. Okay, so it's shared among all objects. So that's different, okay, between instance variable and the class variable. Here, be very careful. And then let's see, we access a class variable here, and we also increment it here. And for our get and set method, I don't think we ever access it, is it? And for toString. And generally speaking, the toString normally is used to describe your objects, is it? And because this is also defined as private, so that's why over here we provide a public method to retrieve the value, as it get a number of time objects. And this method, if you take a look and compare with other one, it also has this keyword static. So this method is called a static, not static, class method. Class method. So it's belong to class, not like this belong to a specific object. So that's the difference between these two, okay? And then let's see what that means. Is it, if you take a look, like this get number, we create our first time object at the second statement, but our first statement, we already try to call that get number of time. Is it? And before it, what we have? We have time. This is what? This is class name, not object. Okay, because this method is class method. So if you use class name, you can access it. Okay, you can access it. And if you take a look at the toString, or get hour, before it, it's associated with what? Objects. T1, T2, they are time objects. Okay, they are objects. This is what? This is class, not object. Not object. So it doesn't exist on heap. Okay, this T1, T2 exist on heap. So that's a difference. Okay, that's a difference. And so we can also show here, is it? So if you say, oh, maybe can I do that time dot get? If you even you see the context is it provided by the compiler, it doesn't have that get hour. So if you try to say, oh, how about I try to call get hour? Then did you see it says non-static method? So it's because it's instance method, is it? So it cannot be referenced from a static context. So this is wrong. Okay, this is wrong. You cannot access it. So the only way you can access the get hour, the toString, etc., is through objects. So try to clear this difference, okay? So instance method versus class method. So class method has that static defined. Instance no static. Okay, so be careful. Okay, then we already fully understand this complete time class. Okay, so let's take a look more about. Let's first take a look at the method. Let's first take a look at this method. Check pass object. And if you take a look at this method, it's what? It's a class method. This is a class method. And if you take a look, further look, in Java, main method must have static. It's a class method. So that means main doesn't need any object to run. And this method doesn't need any object. This has nothing, because this is an application. It doesn't need to be created as an object. That's why over here, the method we put here are all class method. We don't need it to be instance method, okay? So let's take a look here. So first, I'm going to comment out this two statement and get back the T, okay? get back the T, check pass object, check pass object, we do it here. And then we do it here, T1. Okay, and we reset T1's time. We reset T1's time to 10:30 p.m. Is it? So let's take a look. T1 initiated as 12. And let's run to see if it's get change. And the T1's check back, yes. Did you see T1 does get updated to 10:30 p.m. Okay. Let's go back. So let's take a look. If you take a look at this method, it's a pretty straightforward, very short method, is it? So the parameter type is class, okay? So parameter type is time class, is a class. So basically it's a reference type. Reference type, okay, reference type. And then you say T data set. So then you call the set time, is it? So that's why you change the time. But let's take a look why this is working, okay? Why you can change it. Because Java, strictly speaking, it's pass by value. Okay, pass by value. So when we call it, we plug in T1, is it? And we did see T1 change it. And then let's take a look at this check pass primary value, integer I. Suppose you plug in with 100 and you say, okay, I want it changed to negative 100. Will it be changed? Basically, it's not changed. I don't know if, I don't remember if I have this check pass. Yes, we do have. Is it X is 100? And we want to see if X value get changed. And we can take a look where X. Yeah, if you take a look, X not changed to negative 100. So what's the difference? Is it between these two? Why if it's int, it won't change? Why if it's time, then it's get changed? Okay, we can take a look from the memory map, then you may understand it better. So anyway, so here is our stack memory. So we have the main. Is it within main we have X as 100? Okay, and then you call that we call that what's the method we call? Or check pass. Then we call that check pass some value. That method is it? That method initially has that I. Is it? And that I, what we plug in is what? We plug in 100 to that method. Okay, so then you said, okay, I change I to negative 100. It's here. But have you ever changed X value? No, X is still holding 100. So what to plug in is 100, not X. It's 100. So I initially is 100, then it's updated to negative, but X not get updated. So that's the case for this primary value, is it primary data type. But then let's see, for our time. So here we have that stack memory, we have that main, is it? we have the T1 created, and the T1 is created here at 12 a.m. Is it in this memory location? So here is heap memory. Heap memory. Is it? Okay, and then we call that a check, a pass object. Is it? And it's a T. Is it? And what's going to be plugged in? It's this memory block is going to be plugged in on T. Is it? So basically here that means you have this parameter. And here basically it's an argument. And then you pass in. So T also reference this memory block. Is it? T also, so both reference to this same memory block. Then that data set time, 10:30 p.m. 10:30 p.m. That's happened on where? On this memory block. So that's how this changes 30 p.m. That's why you see T1 updated. Okay, because everything is on this memory block. Okay, so make sure to know this difference. Okay, so that's regarding checking this. But here is also some other subtle difference, okay? If I comment out this T set, I do something like this. I have a temporary created. So over here within this check path, you create a temporary object. 23, it's 11:59 p.m. basically. And you assign T to this time. Will this change our T1's value? Because over here, where did I call that? Oh yeah. Because over here, I plug in with T1, is it? So will that be changed? And if you run, you will see T1 not change. So why here not change? Is it? So let's get back. And if you analyze the memory block, so here we have the main, here we have T1, the T1 reference to heap memory. So 12 a.m. here, refer to here. And within that, we create a temp. Is it? Temp create at a different memory location, 59 p.m. something. Is it? And you call that check pass method. Is it? And the parameter is T. So T initially point to here. Is it? Because you plug in with this memory block. So T initially point to here. And then you say, okay, T equals 210. Then this changes the dynamic. Okay, so T doesn't reference here because it's point to whatever temp point. So it's also reference this block. So T also, but how about T1? T1 still reference its old block. So that's why T1 not get updated, okay? So we need to be very careful, okay, whenever you use. So if you do want to do something on T1, then don't reset it, okay? Don't reset it. Okay, so that's regarding this method. We already know. And over here, okay, over here we have this two version of swap. The first one is we using array. And the last class when we learn array, we already learned array can swap, did make a swap occur, is it? And then let's see, where do we can call? Okay, so we have T1, T2, as T1 is 12, T2 is 830. And we first call swap time copy version, is it? And then we want to check if it's swapped, okay? And we first call this one. Okay, so then the question, will this swap the time, the true time T1, T2, is it? So let's take a look at the running result. So before call, T1 is 12, T2, and after call, you see, so not swapped, okay. And but for the other one, if we later on check, it does swap. Okay, does swap. Okay, so why this version not swapped? Is it not swapped? So here in memory, so you have this two time block. This is 12 a.m. That's 8:30 a.m. Is it? So this is T2. This is T1. Is it T1? And then here, initially CPT1 point to here, CPT2 point here. Is it? And you have a temp. You said temp point to CPT1. Okay, temp point here. Is it? Then it says CPT1 point to CPT2. Okay, so this link point. So CPT1 point to 8:30. Then CPT2 point to 10. Okay, this link got broken point to here. Did you see? It's all the arrow change happens on CPT1, CPT2, and 10, not on T1, T2. That's why T1, T2 not swapped. Okay, not swapped. So be very careful, okay, about swapping. And we haven't completed the analysis of the example. So Wednesday, we are going to try to finish the last part of this example. Okay, so that's all for today.